Yeah, hello everybody, good morning. So I am JP Meijers. Most of you have seen my name in association with TTN Mapper before. Just hands up, who have used TTN Mapper? Oh wow, oh amazing. Okay, so that means I don't even need to tell you what TTN Mapper is, but for the rest, TTN Mapper is a crowdsourced coverage map, online coverage map for the Things network. So let's show the rest of you what it looks like. That's TTN Mapper. This is Cape Town. The purple marker there at the top, small bicycle, that is somebody actually mapping coverage at the moment that you visit the website. And somebody here down here, that's another mapper. Blue markers are actually full 8-channel gateways. Yellow markers are single-channel gateways. Red markers are offline gateways. After 5 days, offline gateways coverage are deleted from the map, so keeping the map actual. So who am I actually? I'm the creator of TTN Mapper. Yeah, I don't know if I even should tell that. Anyway, I did an internship with the Things Industries in Amsterdam for a while. That was after I made TTN Mapper. Really interesting what these guys are doing. Congratulations with having this conference. And currently I'm working as a mobile developer at Polymorph Systems in South Africa. So I lived a while in the Netherlands, back in South Africa now, maybe coming back again here. I'm interested in weather, computers, electronics, radio. I'm an amateur radio operator, ZS1 JPM. Those of you that are also hams, hands up. Oh, nice. We should build the Things network together. Like we have the eyesight. Anyway, so I installed a Things network gateway, and my first question was, how well does this thing actually work? So I went to measure it. The pink lunchbox containing a SODOC 1 with a low-pi antenna. Ooh, you can't mix those two. But anyway, and OV-fiets is the bicycles you can rent from the stations here. I cycled 60 kilometers per day on this bicycle around Amsterdam, mapping almost every large street in Amsterdam. So how does the system actually work? Well, looking at the technology behind this, we have a LAMP stack, so I have a Linux VPS, I have Apache, MySQL, PHP, JavaScript for the map, Leaflet, and then I have Python processing data offline. I don't think we have to go into too deep there, but anyway, most important thing is I wrote this thing for myself. I wanted to know how does my gateway perform. So I never intended this to grow this big as it is now. So this is not the right stack for a big system like this, but it still works. But there's better things out there. So making this a community project, what are the challenges surrounding that? So there are 5 main things. Mainly, it needs to be usable by everybody. I need to support a wide range of mapping devices. So you have the Adonis demonstrator, you have the SODOC 1, you have the low-pi, you have some GPS tracker from China. I need to support all those different devices. I need to support Cayenne LPP data format. I need to support custom data formats like my own one. But that's important. You need those to support to get the community contributing data to you. Third one, I need to make the results available to everybody. So the data is public domain. You can download the raw data from TTN Mapper. There's a dumps. If you add dumps at the end of the URL, you can download the raw data, which is public domain. But of course, raw data doesn't mean anything. You need to visualize it. So the online maps, that's available to everybody. But that's tricky to do. So we get back to how to generate the online maps. All of you send me bad data, so I need to filter those out. We get back to that. And the last thing is it needs to scale. Really big issue for me at the moment. So we might need to rewrite the entire system soon. So how do you actually contribute or get data into TTN Mapper? So the first way is you have any device. It can be a Things Uno. You program it to send any data packet. Doesn't matter, it can be empty, it can be a 0. You send it to the Things network. The Things network reads the signal strengths from the gateways, the metadata. Then you have a cell phone, a mobile phone with you running the TTN Mapper app. This app subscribes via MQTT to the things network and receives this packet with the metadata. The phone has a GPS, so it correlates your actual current location with this metadata, and it sends this to TTN Mapper. So now on TTN Mapper, you have signal strength and location, which is what we want for coverage maps. So you don't always want to carry your phone with you. So an alternative is using a GPS-enabled device. For example, here we have a SODAG 1 in this picture. Sorry, I'm using the SODAG 1. It's just the one I had by hand when I wrote the system. The SODAG has a GPS on it, so you geotag your metadata directly there, actually when you send the packet. And TTN Mapper subscribes via MQTT to the things network using an application ID and access key that you provide to me. So the issue with this method is it's not secure because you're sharing your secret details with me, and I can read all your application data. So it's not preferred to do this anymore. We have a better way at the moment. But let's just run through them. If you are really security conscious, the next method is using my API. You subscribe to the things network yourself. You get your data packet in with your metadata. Somehow you geotag those packets, GPS on the device or with your phone or whichever way, and you upload the data to TTN Mapper. The problem is, can I trust the data you send me now because I don't get the metadata directly from the things network anymore? So this is completely not preferred from my side, but a few of you, like the drone mappers around here, they actually use this. Then the last method that is quite new is using the HTTP integration of the things network. So this is actually exactly the same as using the MQTT, but you don't have to share your secrets with me. You just enable HTTP integration on the things network console. You fill in the correct URL and correct authorization header, and you push data to TTN Mapper. In version 3 of the Things Network's backend stack, we are going to replace the HTTP integration with a custom integration. So it's literally a one-click, send my data also to TTN Mapper. So any of you that has a LoRaWAN device connected to the Things Network can, with one click, send data to TTN Mapper and contribute to these coverage maps. So let's see how wide this is actually being used. 6 out of 7 continents. We were still trying to get Antarctica on this map as well, but I doubt it. So this is incredible. This started in Holland. It started in Enschede when I lived in Enschede. It grew to Amsterdam, then Britain, Switzerland, and America was a bit late. South America was actually before North America. South Africa, that's me. But wow, this is amazing. I was really impressed. So let's look at a few stats around this. The red in this graph is actual unique gateway IDs that I have seen on TTN Mapper, well, on the Things Network, since December 2015. So the red line, the red area, includes gateways that went offline, single-channel gateways, any experiments for gateways that were connected to the Things Network. So we can see about 8,500 unique gateways have been seen on the Things Network, and it's rapidly growing now that the Things gateway has been launched. The blue area is actual gateways that have been mapped. So this also includes single-channel gateways, gateways that went offline. And according to this stat, it's 2024. I'm just going to check the latest stats. Measured gateways at this stage is 2,174. Measured data points is 2,981,000 data points. Total contributing users is 1,449. Users today is only 43. We're trying to break that record, remember. The record is 72 on 31 January, so we need another 30 people to map today. And the last measurement was now, 3 seconds ago. So now the trick question is 3 million data points. That's actual data points, 3 million that I have in my database now. I had 4 million contributions. That means 1 million of these data points are already deleted because that's the bad data I was talking about. If your GPS accuracy isn't good enough, if your GPS accuracy is, say, 100 meters, I can't use that data point. I need to know the signal strength in this area. So anything above 10 meters, I have to discard because it doesn't make sense to keep those. So only 3 million or 4 million data points remain. But how do you visualize 3 million data points in a web browser for coverage maps? The answer is server-side aggregation and pre-processing. So I hope this doesn't get too technical for you, but I'm going to run through a few methods how I aggregate data. Afterwards, if you have a better way of doing it, please let me know. This is just a few methods I implemented. So the naive way of doing this is plotting circles. So you have a gateway standing here, you measure a packet here, you say, oh, it's a kilometer, so let's draw a circle of a kilometer radius. That is the coverage area. Well, you have mountains, you have buildings. In some directions, it works better than others. You have outliers. Maybe the GPS point was inaccurate, so it says it's 2 kilometers, but it's actually 1 kilometer. So filtering out outliers in this case, I used the 95th percentile of distance and then I draw a circle. So just looking, this is just a radar plot. This is the default map of the TTN Mapper. You can see about there, this line is the end for this gateway. That's about 50 kilometers, which means you will plot a circle of 50 kilometers. That doesn't mean anything. So taking the 95th percentile, immediately much smaller circles. But this still doesn't mean anything because you might have a mountain between the gateway and the area that shows us covered here. So this is just not correct. So how can we solve this? The next method is breaking the Earth up into a grid of small cell 0.0005 squares, and taking the maximum RSSI of all packets received per cell. This brings the data count from 3 million down to 200,000. 200,000 is still too much to plot on an online map, unless you only plot the ones you can see at the moment. You zoom out, you see the entire Earth 3 times, so you have to plot 3 times that number of data points. It doesn't work, it still doesn't scale. But this is what it looks like. You get a plot like this. The problem here is you have a lot of open areas. You only have the streets mapped. So we are looking for a way to fill in the gaps in this coverage map. So the next method I use is a radar plot. So a 360-degree circle. For every direction, every degree in this circle, you take the maximum distance per RSSI bucket. You take the maximum distance and you draw a line. But the maximum distance, again, is an outlier, so we take the second maximum distance. And in the end, what you get is a nice picture like this. And if you check the previous slide, it actually said it takes my feature count from 3 million up to 4.5 million. But the lucky thing is this is vector data. Vector data can be simplified when you zoom out. So this is much faster to plot than a lot of data points. The problem here is you can see there's a highway going there. Highways in the Netherlands are built on high ground. So somebody drives on the highway, it says you have reception here, and I connect the points and it says you have reception anywhere between the highway and the gateway, which is incorrect. So we need a way to delete from this area you get here, you need to remove parts where you don't have coverage. So the next method I implement for that is called alpha shapes. Alpha shape, think of it as a convex hull. So you have a lot of data points and you take a string and you make a circle, you connect the string around all the data points. That is a convex hull. But now you don't, it's convex, so you actually need concave parts in it. So you want a concave hull. Well, alpha shape is sort of a concave hull. You connect all the points, you form triangles, and you delete triangles above a certain size, certain area, which is alpha, from therefore alpha shape. And what you remain with is actually areas where you have data points, small triangles, and you get a plot like this. So it's much better, but there's still a problem with this one. The problem is it's a single color. Of course, you can do it for different RSSI levels, but then you have overlay of polygons on top of each other. It doesn't look that nice. This is nice and clear. It tells you it works here or it doesn't work here. But we do want the RSSI, the signal strength information in here as well. So what do I do with that? Then I use a point-based heat map. At this point, I should say thank you to Silva and Prost from the Things Network. He helped me playing around with this idea. Basically, what you do, if you have a lot of points at the same spot, you draw a circle for every point. I'm not sure if it's clear, but this middle circle is red. The outer circle is blue. They're exactly at the same location. The blue one is a weak signal, big radius. Red one, strong signal, small radius. So the strong signal doesn't overshadow the weak signal. And you get all the different signal strength values in there. To do this needs to be done offline. I can't do this live when you visit the website. So I pre-processed this into PNG tiles using the Slippy map format, the same format as OpenStreetMap uses. One tile look as follow. This is one single tile. And then looking at this in the wild on a map, this is Stellenbosch, it's the city I'm from. You can see clearly around the gateways you have red spots. On the roads you have nice lines. And the dark blue ones you can still sort of see below the strong signals, the red and the yellow ones. So this map contains signal strength data, and you sort of fill in all the blanks. Looking at a better city like Apeldoorn, get a nice picture like this. All the roads covered, nice in red, and places you don't really know is sort of blue and green. So now my question to you is, which one of these maps do you like most? This may be difficult to say now, so afterwards during the Q&A session you can just tell me, I prefer this one. Maybe we should have an online poll just to vote, because I have limited time, so if I know which one you like the most development time will go into that. So how does other people do this? The two pictures on the left you have seen in the previous presentation from Luca Mustafa, where he mapped using a drone. Then we ran his algorithm on the TTN Mapper data. The problem is TTN Mapper data is really sparse. You only have the roads covered, whereas he has a really regular interval of data points. So unfortunately, his algorithm failed on my data as it is. We're still working on maybe improving that. On the right, you can see Strava. Most of you have seen that in the news lately. It's quite beautiful maps. Maybe we can do something like that. And the middle one is Safecast. They have a really nice map, but they also have a team of people working on that, team of designers. I'm a single person with the help of Timothy here writing the iOS app. So a few final remarks about this project. It's a hobby project. It started as a hobby project, it grew out of hand, and scalability is an issue. But it did answer the question, how well does my gateway perform? There are better tech stacks out there, but I use what I know. Following agile principles, fail fast. It needs major refactoring before we can open source this, but it is our intention. We want to follow the Things Network's principles of open sourcing whatever you have. Remember, there's a workshop this afternoon which you can attend. We're going to teach you how to contribute data to the things to TTN Mapper. And a very important thing that I learned is visualization is key to the adoption of IoT. As I said, I work for a company called Polymorph. We mostly write mobile apps to visualize IoT data. Here you can see a solar power plant generating electricity, nice graphs. This was actually Pick n Pay's actually supermarket in South Africa. They used this on a dashboard in the entrance of the shop. So it's without the visualization, it just doesn't mean anything. As soon as you visualize it, people see, oh, we are actually saving electricity. And yeah, now you have actually people reacting to the IoT you implemented. Then another one is just interesting, the baby monitor there at the top. Baby's breathing rate, temperature, if the baby's sleeping, and so on. Nice graphs. Parents love to use that. Anyway, that's all for now. Do you have any questions or suggestions? You can follow us on Twitter or you can email us. And if there is time, some questions now.
Some time. Well, JP, I'm sure you've made your pink tiffin box quite famous in our community now. You've been quite an active contributor to the Things Network right since the beginning. And I'm pretty sure TTN Mapper has been used by a lot of community members. Whenever I have a call with a community member, they're like, how do I measure my gateway? I'm like, well, there you go, TTN Mapper. There's a labs tutorial as well. Easy to follow, easy to use. My question would be, over the last couple of years, where do you see the evolution of TTN Mapper now that we have so many gateways popping up on the network? How do you see the evolution of it?
Yeah, that's a really difficult question, because up until now, it grew without me pushing it in any direction. I just followed whatever the community wanted. Mm-hmm. So especially the HTTP integration, which we added now a week ago, that was due to requests from the community. even the MQTT importer was request from the community. So I actually I prefer not to answer this question, because that means I'm going to tell the community what I want. Right. It's a community project at this stage. Let's keep it a community project. Whatever you want, tell me. I'll see if I can do it. My focus will be on cleaning up the code and getting it open source so that the community can actually contribute. But yeah, I hope that answers your question.
Yeah, well, I'm looking forward to seeing more features on TTN Mapper and making sure that community members are able to use it easily. We have time for 2 quick questions. Anyone with any questions? Go.
If anyone of you wants a T-shirt, please email me. If we have enough, we can get a few more. Build this community actually as a community.
Could you introduce yourself, please?
Hello, I'm Steve from Milan. In our city, there's a big company that deployed more than 200 gateways, and they did a lot of work to try and map the coverage, doing something very similar to what you showed. So they drove around the city with gateways built, mounted on top of the cars. And we went to the building to install our own nodes for the customers. And what we found is that the results are not good as they were supposed to. And my point of view is that often the mapping work is made outdoors, with people walking or riding a bicycle or a car. And so they map the outside of our space, but this is Internet of Things, and things mostly often are indoors. And the results indoors are not the same as what you see on a coverage map made outside. So this is the contribution I liked to throw in, and I would like to know what you think about it.
Before you give the microphone away, my first question to you is, why are you using LoRa indoors? LoRa is a long-range protocol. It's more ideal for outdoors. Indoor, you would rather use Wi-Fi or Bluetooth. Is there a reason why you chose for LoRa indoors? Is there a reason for that?
The nodes are indoors, and
yes.
The gateways are outdoors.
Okay. So this building, you preferred LoRa to have the gateway far away, not having a base station in the building itself?
Well, the gateways are not deployed by us.
Okay.
They're deployed by a big private company that offers the service, the coverage.
Yeah.
And we are just using...
Anyway, maybe let me just answer this question before the time runs out. Maybe the biggest problem indoors is getting a location. I can take my mapping node and I can walk in a building, but my location is inaccurate. So I can draw indoor coverage maps, but as my location is inaccurate, the coverage will also be inaccurate. So at this stage, it's just difficult to do. If I have a device that does Wi-Fi localization, maybe we can think about this, taking the floors, the stories in a building into account. It's just this system wasn't designed for that. This system was designed for outdoor network. Of course, inside a building with walls in between, that will have effect on the signal strength. It just, at this stage, you can't use a system for that specifically, but maybe it's something we can think of implementing later.
Thanks a lot, JP. And make sure that if you're interested in contributing to TTN Mapper, there's a workshop at 3:30. Feel free to find him.
Let's break the record.
And let's break the record as well. Thanks a lot, JP.